Hello my dear students, welcome to Bright Learning App. Let's continue the chapter, some basic concepts of chemistry. Lot of basic informations we already covered. Now we are going to discuss most important point in this chapter, that is mole concept and molecular mass or molar mass. Very important idea, mole concept. Dear students, mole concept. Already the basic idea we already learned in the lower classes. As you know, it's the most important area, and also you may feel little bit difficult if you don't listen very carefully. So listen very carefully. So dear students, what is mole? Before entering to mole concept, what is mole? You know, simply we can say that mole is a unit. Mole is an SI unit. As you know, in the introduction part of this chapter, we studied 7 base units or 7 base quantities, 7 SI units we learned. In that 7th unit were mole, which represents amount of substance. So simply we can say that mole is nothing but an SI unit. So the next question you may ask, for what purpose we can use this unit? You know, this SI unit mole is used to represent amount of substance. Or we can say that we can use this unit to count the numbers. Count the numbers means we can count the numbers of what kind of substances. You know, we can use this unit to count or to represent its amount of the substances like microscopic particles. That's idea. You know, microscopic particles like atoms, molecules, electrons, protons, neutrons, etc. You know, atoms are very microscopic particle we cannot see even without with our naked eye, isn't it? So if you take a substance, if we take a little amount of substance, any substance we are taking in a little amount, that will contain large number of atoms or molecules and also the subatomic particles. Why? Because that is very smallest particles. So for the convenient calculation and for convenient usage, we must need a unit to represent that large number. When we are discussing about atoms, molecules, electrons, protons, etc., even in a small amount of substance, large number of particles will be there. So to use or to more convenient method to calculate that number of electrons, protons, neutrons, atoms, molecules, etc., we need a convenient unit. That unit is mole. Okay, so basically mole is an SI unit that we can use to measure or count the number of microscopic particles like atoms, molecules, electron, etc. Have it clear, dear students? So this mole or 1 mole represents what number? As you know, we will use a dozen. You are familiar with that? Dozen. We will use dozen. We will use dozen, and this dozen or 1 dozen represents or which implies 12 numbers or 12 items. Suppose we are telling that take 1 dozen bowls. 1 dozen bowl means 12 bowls. Okay, likewise we will use a pair. Pair means that represents 2 numbers, isn't it? Likewise we will use score. Okay, not the score in cricket and football. And another usage, score means 20 numbers. Okay, that represents 20. Okay, and you know there is another word you will use, that is gross. Okay, this represents 144. Okay, so dear students, like a dozen represents 12 numbers, score represents 20 numbers, gross represents 144 numbers, our mole represents represents what number or how much number? That is very important. That represents 6.022 into 10 raised to 23 particles or numbers. Do you remember that number? That is very important. We already learned in the lower classes, isn't it? So before that, before we are learning that number, we must know how can we define mole. Definition is already given here. 1 mole is the amount of substance. Already we know mole is a unit to represent amount of substance. Is the 7th base quantity in a size system, isn't it? So 1 mole is the amount of substance that contains how many particles? That contains many particles or entities. Particles or entities, as there are atoms exactly in 12 gram of carbon 12 isotope. If you are taking 12 gram of carbon 12 isotope, how many carbon 12 atoms are present in that 12 gram? That is equal to Avogadro number. That is equal to 1 mole. That's the idea. I'm repeating, dear students. This simply means, don't confuse, this simply means if you are taking 12 gram of carbon 12 isotope, you know there are 3 types of isotope for carbon. Carbon 12 is there, carbon 13 is there, carbon 14 is there. Among you are taking carbon 12 isotope, you are taking the weight and you are measuring 12 gram, and in that 12 gram of carbon 12 isotope, how many carbon 12 atoms are present? That number is equal to 1 mole. That number is equal to 1 mole. Do you get this? That is equal to 1 mole. So how can we calculate the number of atoms present in 12 gram of carbon 12 atom? Very simple. We are taking 12 gram, that is divided with mass of 1 carbon atom. So we will get a number of carbon atoms in that, isn't it? So first of all, we have to take 12 gram of carbon 12 atom. 12 gram of carbon 12 atom. Okay, in per mole we have to take 12 gram per mole carbon 12 atom. Let's take divided by what? Mass of 1 carbon atom. Mass of 1 carbon atom. Mass of 1 carbon 12 atom in gram. So do you know what is the mass of 1 carbon 12 atom? No, we are going to discuss, that is 1.992, 1.992, not so over, 648 into 10 raised to minus 23 gram per carbon 12 atom. Okay, I'm repeating, dear students. What is 1 mole? 1 mole represents the numbers or entities. What number or the numbers present were 12 gram of carbon 12 isotope. If you are taking 12 gram of carbon 12 isotope and you are getting how many number of carbon atoms in that 12 gram, that is equal to what? Avogadro number. That is equal to what? 1 mole. Okay, that is equal to 1 mole. Okay, so to get that, we have to divide 12 gram with what? Mass of 1 carbon 12 atom. Okay, that is equal to 1.992648 into 10 raised to 23. So if you divide this, we will get the number which is equal to what? Which is equal to 1 mole. Which is equal to 1 mole. Okay, that is nothing but 6.022. 1367 into 10 raised to 23. Here 10 raised to minus 23 numerator when it is moved to denominator when it is moved to numerator, that will be plus 10 raised to 23. Okay, plus 10 raised to 23 atoms per mole. Atoms per mole. Okay, so this is the number which represents 1 mole. Okay, so for normal purpose we will represent 6.022 into 10 raised to 23. Okay, but the complete number is 6.0221367 into 10 raised to 23 atoms per mole. So I am repeating, dear students, 1 mole is nothing but the number of atoms or number of entities present in 12 gram of carbon 12 isotope. Okay, if you find or if you calculate the number of carbon 12 atoms in 12 gram of carbon 12 isotope, we will get 6.022 into 10 raised to 23 atoms. Okay, so we can say that, we can clearly say that like dozen represents 12 numbers, score represents 20 numbers, gross represents 144 numbers, 1 mole represents 6.022 into 10 raised to 23 particles. That may be atoms, that may be molecules, that may be formula units, anything like that. Okay, is it clear? So very important idea and very basic idea also. And as I mentioned in between the discussion, this number also called Avogadro number. This is also called Avogadro number. This is also called Avogadro number. Either it is Avogadro number or Avogadro constant. Both we can use Avogadro number or Avogadro constant. It is generally represented as NA represents Avogadro number, that is equal to 6.0221367 into 10 raised to 23 particles. Generally particles. In the case of carbon 12 atom, that will be atom. In the case of molecule, that will be molecule. In the case of ionic compounds like NaCl, that will be formula units. Okay, so this is the idea. So I am repeating, dear students, one more time. So this is a basic idea we must remember. A mole is a unit. Mole is a unit, and that is the 7th base quantity in a size system that used to represent amount of substance. Okay, and 1 mole is equal to what? 1 mole is equal to number of particles or number of entities that is present in 12 gram of carbon 12 isotope. Okay, that is equal to 6.022 into 10 raised to 23 particles. Okay, like a dozen score gross represents certain numbers, 1 mole also represents a particular number, and that number is called the Avogadro number or Avogadro constant, that can be represented by using Na. A is capital letter, that is not a small letter. If you are writing small letter, we will read as sodium. You know, Na is the symbol of sodium. Okay, don't write like this. Both N and A is in capital letter, but in this way you have to represent. Okay, and one more thing we have to remember, I'm emphasizing that this mole is used to represent amount of particles like atoms, molecules, ions, subatomic particles, like microscopic particles. Okay, for microscopic particles we will usually use the unit mole. Have it clear, dear students? Is there any doubt? Is it clear? Yes. So now, after learning this, after learning the base concept of mole, let me ask a simple question. Suppose I am taking 1 mole. I am taking 1 mole water. 1 mole water. I am taking 1 mole water. Let me ask how many water molecules, water molecule means H2O molecules, will be present in 1 mole of water. Very simple. 1 mole represent 6.022 into completely 6.0221367 into 123. But simple calculation, 6.022 into 10 raised to 23 H2O molecules. H2O molecules will be present in this. Have you cleared this? Have you cleared this? If you are taking 1 mole, we are discussing most basic ideas, the very important. If you are taking 1 mole hydrogen atom, if you are taking 1 mole hydrogen atom, let me ask how many hydrogen atoms will be present in 1 mole? Yes, 1 mole means that is equal to 6.022 into 10 raised to 23, isn't it? So we can say that in 1 mole hydrogen atom, there will be 6.022 into 10 raised to 23 hydrogen atoms. Hydrogen atoms. Have it clear? Yes. Suppose I am taking 1 mole NaCl. 1 mole NaCl we are taking. So we can, you may remember that in the case of ionic solids like sodium chloride, there we cannot use molecular mass. Instead of that, we will use formula mass, because there we don't have a discrete units. Okay, there we don't have discrete units. So we only have formula units. Okay, so we can say that in 1 mole of NaCl, there is 6.022 into 10 raised to 23 formula units. units. Formula units. Okay, so this is the idea we have to remember here. Okay, most important idea. After this, let me make you learn most important another idea. What is, dear students, what is gram atomic mass and gram molecular mass? That is very important. What is gram? Already this is a basic idea we learned in the lower class also, but we should refresh that because the most important idea. What is gram atomic mass? What is gram atomic mass? What is gram atomic mass? Gram atomic mass, GAM. What is gram atomic mass? You know, very simple. Atomic mass means what? The mass of an atom. Usually we will use a relative atomic mass and average atomic mass, formula mass, as you know, one molecular mass also. So atomic mass we are representing in gram. That is called gram atomic mass. Very simple. Gram atomic mass is nothing but we are representing mass of an atom in grams, isn't it? That is called gram atomic mass. Have it clear? Yes. And what is gram molecular mass? What is gram molecular mass? What is gram molecular mass? GMM. What is gram molecular mass, dear students? Yes, as you think in your mind, gram atomic mass is the mass of an atom in grams. So gram molecular mass will be what? Mass of a molecule representing in gram. That is called gram molecular mass. Have a clear? Very simple idea. For example, as you know, if you are taking H2 molecule, as you know, atomic mass, that means relative atomic mass of one hydrogen atom is 1, or that is 1.008, but usually we will for normal calculation we will take as 1. Okay, so here we have 2 hydrogen, so you know the atomic mass will be 2. If you are representing in gram, 2 gram, then we can say that 2 gram is the what? Gram molecular mass. Here H2 is a molecule, so let's change it. We can take one hydrogen atom only. For atomic mass we should take an atom, not take molecule. Okay, for if you are taking one hydrogen atom, we can say that its mass will be 1, isn't it? 1 AMU. You know, we will measure the relative atomic mass in AMU or unified mass U, isn't it? So 1 AMU, if you are taking in gram, we have to take 1 G. Okay, so this 1 G represents gram atomic mass of one hydrogen atom. Okay, if you are taking gram atomic mass of oxygen, you will get 16 gram, isn't it? Because if you take one oxygen, its atomic mass is 16 AMU or 16 U. If you are taking gram, you will get 16 gram. Okay, if you are taking carbon 12, we will get 12. In average, you will get 12. If you are taking nitrogen atomic mass, we will get 14 gram, isn't it? So all things you have to remember. So atomic mass is nothing but mass of an atom representing in gram. That is called gram atomic mass. And what about gram molecular mass? Very simple, you know, if you are taking H2 molecule, you know, this is 2 gram. That means the mass of H2 molecule we are representing in gram. That is called gram molecular mass. Okay, so an example, if you are taking, dear students, H2O, if you are taking H2O, as you know, H2 2 into 1 2 plus 16 18, so you know 18 gram is the gram molecular mass of water, isn't it? If you take carbon dioxide, as you know, carbon is 12, oxygen is 16, we have 2 oxygen, so 32 plus 12, we have 44. So we have 44 gram is the gram molecular mass of carbon dioxide. Have you clear this? So very basic idea, gram atomic mass and gram molecular mass. Gram atomic mass is nothing but mass of an atom we are representing in gram is called gram atomic mass. And what is gram molecular mass? We are representing mass of a molecule in gram, that is called gram molecular mass. Actually this two we already know. So then what is our point that is related to mole? You know, if we are taking, very important dear students, if we are taking gram atomic mass of an atom, if you are taking gram atomic mass of an atom, it will contain 1 mole of atoms. That means it will contain 6.022 into 10 raised to 23 atoms. Okay, that means if you are taking 1 gram of hydrogen, it will contain 6.022 into 10 raised to 23 hydrogen atoms. If you are taking 16 gram of oxygen, it will contain 6.022 into 10 raised to 23 oxygen atoms. If you are taking 12 gram of carbon, it will contain 6.022 into 10 raised to 23 carbon atoms. If you are taking 14 gram of nitrogen, we will get to 6.022 into 10 raised to 23 nitrogen atoms. That means if you are taking gram atomic mass of any substance, it will contains Avogadro number of atoms. That means 6.022 into 10 raised to 23 atoms. And what about gram molecular mass? The same concept. If you are taking gram molecular mass of any molecule, it also contains 1 mole. That means Avogadro number of molecules. That means if you are taking 18 gram of water, no doubt it will contain 6.022 into 10 raised to 23 water molecules. In the case of atomic mass, atoms. In the case of molecular mass, molecule. If you are taking 44 gram carbon dioxide, no doubt it will contain Avogadro number of carbon dioxide molecule. If you take 2 gram hydrogen, no doubt it also contains 6.022 into 10 raised to 23 hydrogen, not atoms, sorry, it is molecules. Have you clear? So we can generally say that if you take a gram atomic mass of substance, it will contain Avogadro number of atoms. If you take gram molecular mass of a substance, it will contain Avogadro number of molecules. Have you clear? So dear students, most important idea we discussed here. First of all, what is mole and definition of mole and its value, and it's called Avogadro constant or Avogadro number. You represented by Na, used to represent the number of microscopic particles like atom, molecules, electron, etc. And also 1 mole of water contains this Avogadro number of molecules. 1 mole of hydrogen atom contains Avogadro number of hydrogen atoms. 1 mole of NaCl contains Avogadro number of formula units. Okay, and after that gram atomic mass and gram molecular mass. Is it clear? Yes. Now we want to know, dear students, most important idea. From this part, lot of numerical questions can be expected. Okay, sometimes they will ask number of atoms present in a given amount of atom. Sometimes they will ask number of molecules in a given amount of a compound or a molecule. Okay, sometimes they will ask number of electrons. In that all kind of question, first of all, we must be able to calculate number of moles present in the given amount of substance. In the given amount of substance, number of moles is equal to what? This is the most important question. Okay, this is the most important question. If you can calculate number of molecules, you can calculate number of atoms, number of electrons, all. But before that, the first step is calculation of number of moles. So dear students, how can we calculate number of molecules? Sorry, number of moles. That's important question. Number of moles. Number of moles. Dear students, for the calculation of number of moles, we have some equations. Based on the situation, we can select the equation. Okay, the first equation, very simple. Number of moles is equal to given mass, dear students, given mass divided by gram atomic mass, given mass divided by gram atomic mass, given mass divided by gram atomic mass. Okay, suppose suppose the question is we are getting 20 gram of hydrogen atoms. 20 gram of hydrogen atoms, and they are asking how many hydrogen atoms are present in that 20 gram. The first step is calculation of number of moles. So given mass 20 divided by gram atomic mass, 1 gram, isn't it? Yes, so 20 by 1, we will get it 20 moles of hydrogen is present in that, isn't it? So this is the first equation we can use to find the number of moles. And the second equation we can use, suppose the question may be related to molecule, not atom. In such cases, we will use given mass divided by gram molecular mass. Okay, so dear students, in the first equation in denominator we have gram atomic mass, in the second one in denominator we have gram molecular mass. Already you know what is the difference between gram atomic mass and gram molecular mass. What is gram atomic mass? A mass of an atom represented in gram, that is called gram atomic mass. What is gram molecular mass? Mass of a molecule, we are representing gram, isn't it? Very simple idea. And as this is in this two equation we can use when the amount of substance is given in gram. In some times they will give the amount in volume. In such cases, what can we do? Very simple. In such cases, the equation for calculating number of moles is equal to given volume, dear students, given volume divided by 22.4. Given volume divided by 22.4. So you will get in the given volume, the given amount of volume, how many moles are present, you will get by using this equation 22.4 liter. Okay, in some cases we will use 22.7. Okay, now you remember this, we will discuss that question also. Okay, so given volume divided by 22.4. So you may ask what is the importance of this value 22.4? We will use 22.4 as well as 22.7. There is some difference in that, we will discuss later that. What is the importance of this? It's very simple. 22.4 means it is the volume. It is the volume of 1 mole. Volume of 1 mole of a substance. 1 mole of a substance. 1 mole of a substance at STP is equal to 22.4 liter. Okay, in some cases we will take 22.7, that we will discuss later. Okay, so what is STP? Somebody may have doubt in the case of STP. What is STP? STP means standard temperature and pressure. Standard temperature and pressure. We have a chapter called states of matter. That is the 5th chapter in the +1 itself. So they will discuss more depth about this STP and also this volume at STP, etc. Okay, so it's very important. I'm repeating, dear students, if the amount of substance is given in volume, we can use given volume divided by 22.4 liter to get the number of moles. Okay, here 22.4 liter is nothing but volume of 1 mole of a substance at STP, at standard temperature and pressure. Okay, in some cases, dear students, in some cases the amount may be given in terms of number. In such cases, how can we calculate number of moles? Very simple, dear students. In such cases we can use given number divided by Avogadro number. Avogadro constant, like Avogadro constant or Avogadro number. As you know, its value is nothing but 6.022 into 10 raised to 23. Isn't it? Yes. So by using this all equations, we have to calculate number of moles in the given amount of substance. Okay, so these are the most important and most usable equations. First, you just go through this equation. Very simple. Number of moles is equal to, you should note down this and mark this. You should by heart this. Without by hearting this, we cannot move forward. Okay, very important. What is the first equation? Given mass divided by, yes, given mass divided by gram atomic mass. Isn't it very simple idea? And the second one is given mass divided by gram molecular mass, then given volume divided by 22.4, then given number divided by Avogadro number. Is it clear? Yes. So this is the way of calculating number of moles. Okay. And after this, we want to know how to find a number of molecules. How to find number of molecules? That's important question. Okay, and number of moles. Number of moles we will represent by using small letter n. By using small letter n, we will represent number of moles. Okay. After this, we want to know the calculation of number of molecules and number of atoms. How can we calculate number of molecules? Very simple, dear students. Let's note this: number of molecules. Number of molecules is equal to, dear students, number of moles. Number of molecules is equal to number of moles into Avogadro number. This is the equation we can use to calculate number of molecules. Number of molecules is equal to number of moles into Avogadro number. So Avogadro number, you know, 6.022 into 10 raised to 23. How we will get number of moles? The above equations we can use: given mass divided by gram atomic mass, given mass divided by gram molecular mass, given number divided by Avogadro number, given volume divided by 22.4. Have it clear? Yes. And how to calculate number of atoms? Number of atoms. How to calculate number of atoms? Number of atoms is equal to number of molecules. Number of molecules. How we will get number of molecules? Number of molecules will get by number of moles into Avogadro number, isn't it? Into atomicity. Into atomicity. This is the equation we can use to calculate number of atoms. You know how to calculate number of moles. That is equal to number of mole into Na. Na is Avogadro number. You know the value. You have by hearted that. And what is atomicity? That's a question arising in your mind. Atomicity. If you are taking H2O, dear students, if you are taking H2O, okay, this contains how many atoms? 2 hydrogen and 1 oxygen. So 2 plus 1, which is equal to 3. So 3 is the atomicity of H2O. If you are taking carbon dioxide, how many atoms are present? 1 carbon, 2 oxygen, 1 plus 2, 3. So 3 is the atomicity of this. So clear? If you are taking sulfur trioxide, we have 1 sulfur and 3 oxygen. So 1 plus 3, 4. So 4 is the atomicity. So atomicity is nothing but number of atoms present in one molecule. That is called atomicity. So by using this equation, we can calculate number of moles. Dear students, by using these 4 equations, we can calculate number of moles. And by using number of moles, we can calculate number of molecules. And by using number of molecules, we can calculate number of atoms. Is it clear? So these are the most important equations we need related to number of moles. So most important area, you can expect a lot of numerical questions. Okay, so this is the most important area. Let's do some simple questions regarding this. Suppose, dear students, suppose the question is, suppose we have a question. In question, suppose they are given 180 gram water. 180 gram water. Okay, and suppose they are asking number of atoms present in 180 gram of water. Okay, what is the question? Find the number of atoms present in 180 gram of water. Suppose that's a question asked in our question paper. So how can we calculate? So the first step, no doubt, that is calculation of number of moles. Okay, number of moles is equal equal to, here water, you know, water is nothing but H2O, you know, H2O is a molecule. So which equation we can use? Given mass divided by gram atomic mass cannot use, why? Because H2O is not an atom, it's a molecule. So the second equation we can take, given mass divided by gram molecular mass, we can use that because H2O is a molecule. So what's the equation, dear students? So selection of equation is very important. Based on the question, you have to select the equation. So given mass divided by gram molecular mass, given mass divided by gram molecular mass. This is the equation we can use. Okay, so which is equal to 180 gram. The given mass already given in question paper, so that is 180 divided by, what is gram molecular mass? The question is about water, H2O. You know, 2 hydrogen is there, the atomic mass of hydrogen is 1, that is 1.008. We can take 1. So 2 into 1 plus oxygen, that is 16. As you know, 18 gram is the gram molecular mass, 18 gram. So 180 divided by 18 gram, we will get it 10 mole. 10 mole is the number of mole present in 18 gram of 18 gram of water, isn't it? So number of moles is get, and the question is about number of atoms. How can we get number of atoms? A number of atoms is equal to number of molecules into atomicity. How can we calculate number of molecules? Very simple. Number of molecules is equal to number of molecules equal to number of mole into Avogadro number. So 10 into Avogadro number, which is equal to 6.022 into 10 raised to 23. Okay, so when we are multiplying a number of moles into Avogadro number, we will get number of molecules, okay, into atomicity. What's atomicity, dear students? In the case of H2O, 2 plus 1, 3. So when we are multiplying this, we will get what? We will get number of atoms. I'm just giving the idea, not giving the final answer. So this is a way of finding number of atoms. Okay, so the first step, finding the number of molecules. So number of moles, not molecules, number of moles. Okay, then when we are multiplying number of moles with Avogadro number, we will get number of molecules. Again, we are multiplying with our atomicity, we will get number of atoms. Have it clear? So this idea. And let us take another question, dear students. Another question. What's the question? Suppose 48 gram of helium is given. 48 gram of helium is given. Okay, the question is how many helium atoms are present in 48 gram? How many helium atoms? How many helium atoms are present? This is the question. So what is the first step? First we have to find number of moles. How can we find number of moles? Given mass divided by, yes, given mass divided by helium is an atom, it's not a molecule. So gram atomic mass, isn't it? So which is equal to, given mass is 48 gram divided by, you know, helium having atomic mass 4, so divide by 4 gram. Okay, so you know, first few elements you must by heart the atomic number. Okay, no, not atomic number. Atomic number is definitely you must remember, and also the mass number also. Then only we can solve this kind of questions. Okay, sometimes they may given the atomic mass of each element in question itself, but sometimes they will not give. Okay, in such a cases, to find the correct answer, you must be able to by heart that. Okay, then only we can write. Okay, so 48 divided by 4, you know, which is equal to 12. So 12 mole helium atoms are present in 48 gram. So the question is about number of helium atoms. Number of helium atoms is the question. Number of helium atoms is the question. So number of helium atoms. Number of helium atoms is equal to number of moles, that is equal to 12 into Avogadro number, then only we get a number of molecules, that is 6.022 into 10 raised to 23. Okay, into atomicity. What's atomicity of helium? Here we have only one helium, so we have to just multiply with 1. That means in the case of helium, number of molecules will be equal to what? Number of atoms. Okay, number of atoms will be equal to number of molecules. So this is the answer. I'm not writing the final answer. This is a way of solving this kind of questions. Have you clear this? Okay. So dear students, let us do another simple question. We can expect this kind of question from this part. I'm taking 6.022 into 10 raised to 25 6.022 into 10 raised to 25 oxygen atoms. Oxygen atoms. Okay, so the question is, what's the number of moles of oxygen? Number of moles of oxygen. Okay, or the question is number of molecules. Number of atoms of oxygen. How can we calculate? Very simple. Here the number is given. So how to find the number of moles? Number of moles is equal to, here we can use given number. Here we can use given number divided by Avogadro number. This equation we can use here, isn't it? So given number is equal to 6.022 into 10 raised to 25 divided by Avogadro number 6.022 into 10 raised to 23, isn't it? So this will cancel each other. Here we have what? 10 raised to 2, which is equal to 100 mole. 100 mole will be the answer. Okay, so 100 mole oxygen atoms are present in 6.022 into 10 raised to 25 oxygen atoms. Have you clear? Have you clear this idea? This kind of question we can expect. Okay, and let us take another question. I'm taking 240 liter of water. 240 liter of water. Okay, students, 240 liter of water. Or instead of water, you can take any other gases also. Let's take our oxygen gas. 240 liter of oxygen gas or oxygen molecule. Okay, 240 liter of oxygen molecules are there. Okay, my question is, in that 240 liter of oxygen, how many oxygen molecules will be there? How many oxygen molecules will be there? How many oxygen molecules will be there? It's a question. So to find the answer, first question is find the number of moles. As you know, here it is given in liter, that's a volume. So given volume, so our equation is given volume. So equation is given volume divided by 22.4. Okay, here we are using this, and you know there's another 22.7 also, we will discuss later. So 22.4. So here we have 240 divided by 22.4. 240 divided by 22.4. Okay, so when you solving this, what will be the answer? You know, you will get a 10 mole you will get, and the question is a number of molecules. So 10 in number of molecules, number of O2 molecules. Number of O2 molecules is equal to 10 into 6.022 into 10 raised to 23, isn't it? So we will get 6.022 into 10 raised to 24. So this will be the number of oxygen molecules present in 240 liter of oxygen. Have it clear? So this kind of numerical questions we can expect from this part. Okay, so mole concept and molecular mass is a very important area. You have to expert lot of numerical problems from this area to find number of atoms, molecules, number of moles, etc. Okay, you must be very clear about this area. Okay, so the basic things we already studied in the lower classes. So because a simple and important and a thrilling area, a lot of questions we have to work out, then only we get thorough from this area. Have you clear? Yes. So dear students, one more point we have to discuss here in this video, that is percentage composition. Percentage composition. If you are taking a compound, definitely there will be more than one element. If suppose there is only one element, we will not call it as a compound, isn't it? Suppose we are taking a compound, it will contain more than one type of elements. Okay, so we can say that in a compound there will be more than one type of element. So what is the percentage of one element? That's a question. What is the percentage of one element? That's a question. Okay, what is the percentage of one element in that whole compound? That is called percentage composition. Okay, what is the percentage of in mass? Actually, we are taking a compound. There are a lot of elements. Definitely, more than one type of element will be there. And in if you are taking the percentage of one element in that whole compound, that's a percentage of that particular element. That's the idea. And we have an equation for that. Mass percentage of an element is equal to mass of that element in that compound. Mass of that particular element in the compound divided by molar mass of the total compound into 100. So this is the equation we have to use to find the mass percentage of an element. Okay, so dear students, mass percentage is an important question. We can expect 2 more questions from this area. So that is the percentage of one element in that total compound. Okay, that's a percentage of that particular element. Suppose we are taking water molecule. You can take this. We can take water molecule H2O. You know, this is a compound. This compound contains 2 components. Which are the components? One is hydrogen atom and second one is oxygen atom. Okay, how to find the mass percentage? How to find mass percentage? How to find mass percentage of hydrogen? 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 Very simple. Mass of hydrogen in this compound. Mass of hydrogen. Here we have 2 hydrogen. So 2 into, what is the mass of one hydrogen atom? You know, generally we will take 1. If you want to get the accurate mass percentage, you can take the accurate mass 1.008 divided by what? Total mass. What's the total mass of water? You know, that is 18.02. Okay, into 100. So you will get a mass percentage of hydrogen in that compound, that is equal to 11.18. 11.18 is the answer. Okay, and how you will get the mass percentage of oxygen? Mass percentage of oxygen in this H2O. Very simple, that is mass of oxygen divided by total mass of water into 100. So you know what is mass of oxygen? That you generally have to take 16 divided by what is total mass? 18.202 into 100. So you will get the mass percentage, that is will be equal to 88.79. Okay, if there is only 2 components, once you get the mass percentage of first one, then the next you not need to calculate. If you just subtract from 100, you will get the percentage of the second one. Okay, so sometimes there will be more than 2 components. In such cases, the last one only you will get by subtracting from the 100. Remaining all you should be calculated. Okay, so equation you have to remember. So if you want to calculate the mass percentage of a particular element in a compound, take the mass of that particular element alone in that compound divided with the total mass of the compound into 100. Then we will get the mass percentage. Have you clear, dear students? Any compound may given, and we must be able to calculate the mass percentage. Okay, we want to able to give the definition as well as the equation, and we must be able to calculate this kind of questions also. Okay, have you cleared this? So very important area, dear students. In this part we mainly discussed the mole concept and molecular mass, then mass per. Only two concepts we discussed here. So mole concept is a very important area. Numerical questions, you have to practice lot of questions and make thorough that area. Okay, are you fine? Okay, thank you, all the best.